Hello everyone and welcome back to another episode of the Func Prog podcast with me, Christopher. Today I'm talking to Gabriela Moreira, who is the lead developer of Quint, which is a modern and executable specification language. So Gabriela's background is in type systems and formal verification, but right now she's working at Informal Systems, developing Quint full-time. Welcome to the podcast, Gabriela.
Thank you.
So I just want to ask you, how did you decide to get into type systems and formal methods, etc.?
The way I started was on the first year of university. There was this talk by someone called Marcelo Camargo on Haskell. He was just presenting Haskell. He was a bit crazy, and then my first semester, I didn't even know how to program yet. I was very lost, and then I saw that talk, and I'm like, okay, this is good. And so I learned Haskell as I was also learning C, or even before I learned C almost, which I think made all the difference, because I got that functional programming thing in my head very early on. And then I had a very easy time learning functional programming and it's actually the time. So this was on the 5th or 6th semester. We actually had a class on functional programming, and then I was super good at that class because I already knew how to do it, right? So my professor was very impressed by that, and then he offered me you have this kind of scholarship thing. It's not really a lot of money, just something to incentivize you to start doing research at the university. So it was a small thing, but he offered me that scholarship. So I started working with him, and I was at the time doing something else that I was not very interested in, with networks and stuff, not my thing. So I switched to this, and I immediately loved it. He started presenting to me that talk by Philip Wadler on proposition as types.
Yeah, that's a good one.
I fell in love with it and started doing it. So I worked with him for a year on this type systems, and wrote a paper with him, with his professor. And then I kind of started working on the industry, and then didn't have a lot of time for it. And for formal methods was a bit different. I was always a bit, the crazy person that likes functional programming in the environment. And one of my colleagues at work, he saw TLA Plus somewhere, I don't know where. And at some point we were having beer after work at the office. He came to me and I saw something and I think you really like it. And then we opened the Lamport's website on my computer and started looking at TLA Plus, and I was like, this is amazing. How can I never heard of this before? And then I just, that's what I want to do. That's why I would do my bachelor thesis on. And then my professor was on board, and then that's how I started.
Okay. Yeah, that's interesting. So he was I think this is something that Gabriela is going to be into. And,
and I was that right. Person somehow. Yeah, he was right.
Yeah. But so just to rewind back a little bit, that paper, was that the paper you wrote on Gadgets?
Yeah, that's the one.
Okay. Yeah, let's see if hopefully we have time to dig into that as well a little bit. But
if I can remember something about it, it's a bit long time ago in my head.
It was a few years ago, right?
Yeah, it was 2018, if I remember. So this is 7 years ago, which is if you put it in some terms, it's kind of 1/4 or 30% of my life, So it feels like a long time ago.
Yeah, let's say if we have time, I would really love to dig into that. But I think you said something really interesting, that when you were learning C and Haskell at kind of the same time, and that you sort of found Haskell to be quite intuitive or easy. Was that the word you used?
Yeah, I think at start, the first impression was not that this is easy. It was more this is interesting. But I think the fact that I was introduced to those concepts such early in my programming history, that made me. Because I guess when people just learn imperative programming or even object-oriented programming so much before they learn functional programming, then by the time they learn functional programming, they already have their brain set to think in the imperative way. And I never had that. I never had my brain just like formed into the imperative setting. I always knew that there was these two ways of programming, and I always had the functional one in mind as well. So I was never like molded into one and then had to switch, because switching sometimes is the most challenging part, right? When you already know something and you have to learn to do the same thing in a different way. But I never had to do this switch because from the bat, I already knew a bit about functional programming, and I was already trying to do some coding and experimenting, so I got that functional thinking into my head very early.
Yeah, that's very interesting, I think, because just like you said, it's like sometimes it's harder to unlearn what you have learned in order to learn a new thing rather than starting from scratch. And I mean, a lot of people keep saying like, oh, Haskell, it's so difficult and it's so academic. But sometimes I think that like maybe it's not really the fact that, functional programming or Haskell is difficult. It's more like it's so different to what you're used to. Kind of like, I mean, if you know French, for example, then it's not that big of a leap to learn Spanish, right? Because they are kind of similar. But it's very difficult, or it's much more difficult to learn Chinese because it's so different. But that's just because it's not what you're used to. Like if you're born in China, then Chinese is not difficult. Then it's like the other way around. It's much harder to learn. Then it's hard to learn French or Spanish all of a sudden.
Yeah. For me, you can say that I was born into functional programming, and then I guess one of the challenges is for me to really understand the difficulties that people have learning functional programming. So when I'm teaching, even teaching Quint to people, because Quint is very functional, I often find hard to understand some difficulties and know how to explain things around it. Or even I saw this meme the other day where they had I don't know if you know that meme, but there's a person, a man pointing to colors, and then he sees blue, yellow, green, and then there's on the other side the woman, and then the woman sees so many more colors. That's not the important part, but it's they use the same meme. And one of the man was looking at something we have try catch, async, retry, state space. I don't know, there was a bunch of programming concepts, and the woman would just say monads. And I think I sometimes kind of have that difficulty because in my head kind of everything's kind of a monad in a way, and sometimes, and also it's kind of hard to understand or to explain why something is like this or something is like that. So for example, in the Quint code base, some things are functions that take some parameter that's that manages the state space, and some others we have the class to manage the state, and then you have methods. And what's the difference? There's no difference. It's the same thing in my head. So I don't know which one to use. You tell me. I don't know, what do you want me to use? I do have some difficulty in that way. But it's interesting to have started with functional programming, and it's so I think it's such a strong advantage in a way that we actually, after a few semesters or after some years, the university I was on, they changed the curriculum, and now they have functional programming in the very first semester.
Oh, really?
They changed the curriculum to move it, and it's been good. I think it's not super successful because they see functional programming on the first semester. They learn Haskell, the very basic things. They cannot really go very deep, right? Because it's the first semester. Yeah. But they don't see Haskell kind of ever again until the end of the course or something. So they tend to forget. They come to me. So I'm also teaching formal methods at the university, which is very late in the course. So I think 7th semester or something. But when they come to me, they struggle with functional programming. They learn it in the first semester, but they don't remember a lot. But I think it's still better than having to learn late, because they didn't have to unbreak any concepts.
Yeah, but I can understand that, because I remember it was kind of the same thing for me as well. It's it takes some time to sort of rewire your brain, because you're so used to thinking about this a program as a set of procedural steps, and you're not really used to thinking it in terms of data transformation and inputs and outputs. It's more for example, I used to program a lot of games when I was younger, and then the way you think about it is usually like, oh, this thing happens. How does this affect the game state? Like, does it change the state of an, like, some like if a bullet collides with an enemy, for example, then that enemy should be removed from the list of enemies, etc. And it's all like your brain sort of works in imperative, like, but and it's really quite like, I mean, if you compare the two, just like that example with like, I mean, you can have all kinds of different like control flow constructs like async await and try catch, etc. And then, but if you think about it, like, yeah, you can model all of those as monads. So like, the monad concept is actually simpler in a way because all monads sort of behave the same, but you're so used to having all this state around, and like, that's sort of how you intuitively think about programming. So yeah, like we said before, it's really hard to like sort of go back and rewire your brain. But I'm very happy to hear that they are introducing functional programming early. So I remember my school, they changed the curriculum from starting with Scheme to doing Java instead.
Yeah, kind of crazy. Yeah.
Yeah, and I don't want to like I don't know, hate on Java too much, but it's like it's not really a good. I think it's very hard to argue that it's a good language for beginners.
Yeah, it shouldn't be the first language someone learns. I think it doesn't serve any benefit unless the person just wants to go straight into like a job in the industry and not worry about.
Yeah, but I mean, then you have like, you have vocational colleges for that kind of thing, right? Like where you just need to learn a trade. I mean, if you want to really build a solid foundation, I think it's a really good idea to start from like, simple foundations. And I mean, you can't get much simpler than Scheme, for example.
Yeah.
And like you said, you were teaching as well, formal methods.
Yes, it's like a temporary lecturer at the university. It's not like a big thing. I just teach formal methods, which is just like almost like 4 lecture hours a week, a single class. I started last year, so it's my third semester teaching. It's very fun, very pleasant, and it's very challenging as well. Yeah.
Yeah. But I mean, I've been teaching a bit as well, but it's fun, right? Like you said, it's very.
It's interesting. I like preparing. I like the biggest challenge for me was preparing the material because the previous professor was teaching Coq, which is now Rock. So we didn't have, and I don't know a lot about Rock, so I could not teach that. The idea was I would go in and teach TLA and perhaps Quint, because that's what I know, and it also fits the curriculum. The curriculum is very open, so it's kind of like you can teach pretty much any formal method. It's just for them to be introduced to this world. So I had to prepare everything from scratch, like every assignment, every exam, every single class. I didn't have anything, so that was very challenging. The first semester was like a lot of work, and now I just have to kind of like repeat the stuff, just change something here and there. But it was very interesting, and I did this very fun assignment for them for like the main assignment of the semester. They do this RPG game where there are some like characters, like the mage and then the hunter, and then every one of them has a special skill, and they have to defeat the monster. But this is just like a metaphor for distributed systems and protocols. So you have the whole system of the game is kind of like a metaphor for your distributed systems, and then you should have a strategy. You have to define a strategy or a protocol to beat the monster or to like do something in your distributed system. It's obviously not as complex as a distributed system, but you do have some fun stuff about like the order in which the players play, which is like the initiative on RPG games. The initiative is like non-deterministic, just as the order in distributed systems is also non-deterministic. So you have to consider all the possible orderings. Like if the mage comes before the hunter, then the mage has to do something for the hunter. Otherwise, if the hunter plays before the mage, you also have to consider that scenario. So it's challenging still. Like it's not super obvious to come up with a strategy because you have to consider all the orders in which they play. And then you use the Quint simulator to make sure that your strategy is good enough, or you can also model check and make sure that your strategy is good enough. And that's kind of like what they do for the assignment. So it's not like super heavy because also some of them have not learned distributed systems yet. So I cannot really ask them to do something super complicated. So I managed to get like the complicated thing in a I don't know, simpler environment for them to work on, and I think it's a bit fun.
Yeah, it sounds like a super fun assignment. I love that. Like, you know, we can get like, I guess the students like it as well.
Yeah, I think so. I don't know. Like, they don't tell me, but I hope they like it. I hope they don't hate it. They don't like assignments in general. But
I don't know. It feels like you're putting up like, you know, it's if you start with like, you know, modeling in an RPG game, I think you are setting the bar quite high. Or like, it sounds more fun than a lot of the assignments I've had at university.
Yeah, I like it. I have fun, so that counts as well.
I think I'm very happy to hear as well, like, you know, that's something I also would like to get into later, like, you know, the distributed systems, because like if you think about it, like distributed systems are so pervasive nowadays. Like almost everything is a distributed system, and it feels like we are not really. I think schools could do a better job of like preparing students for working in this kind of environment, and like learning a model checker sounds, or like formal methods sounds like a really good way to like, you know, get an intuitive sense of how distributed systems work and how they can, and well, how they not work if you make a mistake.
Yeah, and I think the biggest problem is when people go to work on something that ends up being a distributed system. Perhaps they don't even know that it is, and they are too naive and they don't realize how hard it is, because it is hard. Like you have to think about so many different scenarios, so much different orders and interleavings, and some people don't realize that. I remember an example. Some person told me that the company, they had this screen that would load something like from the database and then show some records on the screen, and then the user would select one to be like deleted, right? And then there was this concurrency problem, right, where like this was loaded onto multiple screens and then some of them deleted, and then suddenly this other person was seeing something on the screen that was really not there anymore because it was deleted, and then they could delete it, and then there was a problem. So it's a very simple one, and still there's so many people who wouldn't be prepared to handle it because they didn't learn any better. So yes, I think it is a problem. And teaching formal methods, I do try. Like they do have a distributed systems chair, which I don't know how it's these days. Like I've had that years ago, and I'd learned much more about like the RPCs and ways you can exchange messages than the actual problem. So I didn't have a very good experience. So I do try to teach them about the problems of distributed systems without going too much into the details. Because what I tell my students is, I'm telling them what an umbrella is, but those who didn't take distributed systems yet, they don't even know what rain is. So I have to teach them a bit about rain so they can see what the value of an umbrella is.
Yeah. You're like, you know, what is this thing good for? Anyway.
Yeah. And then I go and I talk to them about like Byzantine messages, Byzantine generals problem, and a bit about like two-phase commit. And I try to make it as easy as possible. Like the two-phase commit, I explain about this little guy named Thomas, and he wants to book the hotels and airplanes for his traveling. He wants to make a trip, but he only wants to book the hotel if he has a ticket, and also the other way around, right? He doesn't want to end up like with plane tickets but no hotel, or hotels and no plane tickets. So he goes and has a fancy strategy. He opens the website, puts the hotel in the cart, make sure that there's a reservation, and then also with the plane, and then he goes back and confirms both. And this is just through a phase commit protocol in like a very simple way, and assuming that the websites will actually work, which is not the case in real life, but yeah.
Yeah, and that's the thing. Like, if you look at a lot of like HTTP APIs, for example, it's almost as if sometimes the authors don't seem like unaware of these problems either. So, for example, like it feels you're lucky if you see like a REST API that has some kind of like idempotency mechanism, for example.
Yeah.
In a lot of cases, like you have to try again and sort of hope that it works, and like it's really good to like try to make people more aware that there even is a problem.
Yeah.
That also feels like a very good like pedagogical strategy to sort of like to make the students interested. You sort of have to motivate them first, like show them like this is the problem, and now I'm gonna give you like a solution, because a lot of the time, like if you just start talking about like consensus problems or whatever, people don't like maybe that's relevant if I'm working on a cryptocurrency protocol or something, but I just want to build like CRUD applications, but I mean you're gonna have those problems as well. But yes, if we backtrack a bit, you mentioned Quint. Maybe it's time to get into like what is this Quint thing?
Okay, yeah. So Quint is a formal specification language, so into the formal methods field. And it's kind of like it's modern. So we try to make it feel like you're using a formal method in 2025, which is not the experience you get on most existing formal methods, because they are often quite old and then haven't really been like updated into what we are used to having today. So it's completely based on TLA+, which is a very well-established formal method, formal specification language designed by Leslie Lamport. And TLA+ is great. Like it, as I told you before in my history, like that's how I started with formal methods. I loved TLA+, and I still love it. But it is hard to learn, and I loved it, and I was super interested because I was already so much into it. Like I really wanted this stuff. But for people less motivated than me, which is most people, they struggle to learn it. Like they don't like so many aspects of it. And the tooling bothered me and bothers a lot of people. The tooling is not really what we would expect from a tool in 2025. So what we wanted is like we took the good stuff about TLA+, which is the semantics, the logic. We kept all of that. So that Quint has the same semantics as TLA+, the same underlying logic. We can transpile any Quint specification into a TLA+ specification, so we can leverage all the existing tooling if we want. But we have like the syntax is made for programmers. TLA+ syntax is made for mathematicians. So So if you're a mathematician, don't try Quint. Just go into TLA+. TLA+. Mathematicians love TLA+. It's great. But for programmers, it's super hard. And the things that are easy sometimes for mathematicians are not easy for programmers. So Quint is for programmers, and we try to make it as familiar as possible, because also it's probably not going to be the primary language someone uses, right? They probably have their job, they work with like Java, or they work with Clojure or whatever, and then that like sometimes they have to go into Quint to model something. So it's not going to be a primary language. So we try to make things like super easy to remember, and if there is some sort of like the primitive is kind of like, if there is something that's well established in programming languages, we will just do it the same way. Like we are not going to reinvent something. We want it to be familiar. So for example, like for lists, the indexing starts at 0.
So like given like one indexed in TLA+ or
so TLA+ starts with 1. which I guess is natural for mathematicians. So but there are a bunch of like small things like that. And so it's modern, and for people, so it's kind of like, I don't know, I'm speaking here thinking about like an audience who already perhaps know about something about formal methods. But if you don't know, so this is what I spoke now. But if I want to speak about to someone that's never heard of formal methods and perhaps is writing like so if you want to solve a problem, have some problem at work, perhaps it's a distributed systems, perhaps it's a little bit more complicated, you want to solve something, you go and open your Google Docs and write what your solution is going to be. Or perhaps you start a markdown document to upload to GitHub with your design architecture. You make some sort of design beforehand if you're making a complex solution. Using Quint instead of that is better because it makes sure that you're not missing anything. It makes sure like your types are correct. You're not saying like, oh, I'm going to model this as like this process is going to send a message to this other process like this, and then perhaps you forgot type, you made some type mistake, or perhaps you forgot to model something. And Quint makes sure you have all of that set up. But then you can say to me like, oh, but a programming language can also do that. But when you're programming something, you go so much into detail. You have to say like, oh, this is an RPC message, or maybe perhaps this is like a message that goes into a pub sub channel or something. But that's not the case with Quint. In Quint, you can be very abstract. So you can just say like, a message goes into a set of messages. And I don't care what this set of messages is. It's just a set of messages. And then a message is taken out of that set of messages and processed. So you can stay on a very abstract level, the same level as you stay on your like design document in Markdown or something, but you can be precise. This precision problem is like a big thing, because often when you write specifications in like plain English or even in pseudocode, there's almost always ambiguities and lack of precision, because there's nothing enforcing you to be precise. And then someone goes and reads your document, reads your pseudocode, and tries to implement something, and then they can just introduce mistakes because they interpreted something different than what you mean. So Quint adds that level of precision, and that's where I think it's the most valuable. But perhaps the main point is that you can formally verify then what you have written. So besides all of the like checking if your types are correct and keeping things on an abstract level, you can formally verify that something is true on all of the possible scenarios that you have in your model.
Yeah, because that's like, where people go wrong most of the time, right? Like, this kind of like non-obvious edge cases where you don't really think like, oh wait, if these things happen in this sequence, like, my model is actually broken. But and sorry, I just remembered, like, I think I saw someone on Twitter post something like, oh yeah, Quint is like TLA plus for Zoomers.
Yeah, maybe it's modern. So, and what do I mean when it's modern, right? So probably if you never use TLA plus or any other formal specification language and you go to Quint, you would not understand what I mean by modern, because it's probably going to be a similar experience to what you have in programming languages, but also taking account that it's kind of like a new language, so it's not like super, like the tools can not be super perfect, like your or like auto-completion is not still like completely amazing, so you can find some struggles, but like overall you feel like you're just using a normal, like just learning another programming language, right? But if you have used any other formal methods before, you'll probably see what I mean by modern, because these formal methods, like for example TLA+, they do now have a VS Code extension. They for a few years now. But for example, if you type something wrong, so if you make a syntax mistake, right? If you type like a % there's not supposed to be there, it will not tell you anything. It can continue typing, and then at some point you try to run the model checker. And then when you run the model checker, it will highlight the error and say, oh, you have an error actually there on line 100. So it's okay, but like you don't get the error as you're typing. In Quint, you get the error as you're typing.
Interactive, like
so it's like
feedback.
A very minor thing, right? Like Quint, you can press what is in VS Code like F12 and go to definition, right? As you would in any other programming language, but that's not the case with TLA+. So it's just missing some of the stuff that we normally expect in 2025 when you are working on a language. So yeah, we try to make Quint just feel like a normal language. In the tooling as well, like not only on the editor, but like if you use the CLI, if you use the CLI Plus tooling, you have to like install a jar and then you invoke some class path, and then there is like a CLI wrapper that someone did. But it's a bit of a headache. While Quint is just like use npm install and then you just invoke it as a normal CLI, and it's all very like straightforward.
Yeah,
so that kind of thing.
Yeah, before this, I actually downloaded Quint and tried it out in VS Code, and I have to say it was very smooth, like, very easy to get started with. Like, just download Quint from npm, like you said, and then, download the VS Code extension, and you're off to the races. Like, I'm not very experienced in formal methods. I've never coded a single line of formal methods before, but I found the whole Quint experience quite intuitive. So I think you've done a really good job there.
Thank you. That's the goal.
Yeah, and from what I understand, like you said, like TLA Plus, it's like it doesn't really have a type checker, right? I mean, you type check it by essentially running the program, as far as I understand. So, but Quint having a type system also helps a lot, especially when you're a beginner, because you're like, oh, okay, you sort of get those guardrails that tell you, like, okay, you went off the rails here, like, this is not going to work, so can go back and fix that, and you don't have to, like, write the whole program, and then realize you made a typo, like, somewhere down the middle. Yeah,
I don't know, I am a big believer in types. So yeah, I do think it's very helpful. And yeah, TLA Plus, you would, like, if you make a type mistake, that will only happen deep down into like the state space, so like not in the initial state, but like further down the line, then you would only get the type error when the model checker tries to inspect that state down the line. So it's really like a runtime error. If there is a runtime in model checking, but yeah. And yeah, I do think the types help a lot. I think, so TLA Plus, very important thing about TLA Plus is that it was not originally created to be involved with any automated tooling. So it was just something to write, so like on paper, quote unquote, but actually on LaTeX. So to write on your papers. So Lamport noticed that even he, who is super smart and a brilliant person, super advanced, he was not writing super precise definitions of his algorithms. Because Lamport writes a bunch of algorithms, right? He wrote like Paxos and stuff. And he noticed that he was not being like 100% precise. He had some ambiguities on his paper. And he was like, if even I'm making these mistakes, imagine everyone else. Like they must be making terrible mistakes. So that's what I'm kind of like exaggerating a bit, but it was something like that. So Lamport decided to create TLA Plus, which was just a language to define algorithms in a precise manner. He created that, and he didn't think initially that there could be any model checking for TLA Plus. He was like, no, he didn't plan the language for it to be model checkable. So he just created like the syntax, and he didn't thought it was possible. But then someone else came and tried to do it, and he helped this person. I don't remember his name, sorry. And then they came up with TLC, which is the model checker for TLA Plus. So they managed to make it work, but it was not natively made for that. So of course it doesn't have types. It was just supposed to be something that you write on paper. And then of course, like there are still some constructs to this day that cannot be model checkable. Like if you write that, it just won't work because they cannot figure out how to do it, or it's impossible to do it. So and also like the language is super hard to parse. The parsers are super complex. So that's also like one of the first motivations for us to write Quint, because like we couldn't even like write our own parser for TLA Plus in like feasible time. So it's kind of hard to write tooling for it.
Then maybe it's better to like just start from scratch. But I was thinking, like, for those who are not familiar, like, I think you made some really good examples so far, like with the like role-playing example and the like the two-factor commit, etc. Two-phase commit, etc. But like for people who are not familiar with this kind of like formal methods and model checking, like I mean, what does it do basically? Like if you can explain it on a very basic level, like you have a bunch of states, right?
Yeah. So before you have a bunch of states, in order to have a bunch of states, you have to define your model. So I like to explain this in terms of input and output, right? So the model checker is a tool that takes 2 inputs and produces 2 possible outputs. So the inputs are the model and the properties. The model is a state machine. So to be more precise, it's like a transition system, normally a cryptic structure, but that really doesn't matter a lot. It just means like a transition system that doesn't have any deadlocks. But you can have deadlocks, it's fine, you can work around that. But a transition system, so you have states and transitions. You have circles and arrows, and that's your model. But instead of drawing circles and arrows on paper for defining your model, you use the Quint specification language, which is like a high-level abstract language to enable you to write the state machine. So it's a good language to define state machine, so you don't have to draw a bunch of circles and arrows. And the other input is the properties. So the properties in Quint, you also write them in Quint. So you use the same language to write the properties. This is also true for TLA+, but not true for many other formal methods. Usually you have to learn 2 languages, one for the model and then another one for the properties. But for TLA and for Quint, they're usually not the same. Because usually the properties are usually just temporal formulas, which is the case in Quint. But the thing in Quint, in TLA, the model is also like down the line of temporal property. That's a bit too theoretical, but it's the same language. So you write your property. So your model would be something like, I like the bank example, which is the one we have on the website. So if you check the Quint website, that's the first thing you'll see. The bank example, so it's a model where people can start with like 0 money on the bank, and they can deposit or withdraw from the bank, right? So I can make a deposit of 100 money and then withdraw 50 money. I say money because you can say like dollars or whatever. And then that's your model. So there's like it's evolving over time, right? You start with 0, and then suddenly you have 100, and then you have 50, and then you have 80. It's evolving over time. And your property can be something like balances are never negative. So that should never be true in bank, right? I don't know, like perhaps some banks, but like let's assume that
credit card.
Let's assume you cannot have a negative balance. So like in crypto, for example, this cannot be the case. You don't have crypto credit, as far as I can tell. So you should never have negative balances on your crypto wallet. And then, so that's the input. And then the output of the model checker, it can be 2 cases. It will either say, okay, and then that just means that it verified all of the possibilities, and it is true that you can never have empty balances. Or it will tell you, no, there's a violation. And in that case, it will always give you a counterexample, which is a precise sequence of states that lead you to a violation. So like you start with 0 money, and then Alice transfer 50 to Bob. Or sorry, I didn't introduce transfer. So Alice withdraws 50, and then suddenly Alice has minus 50. And then that's like a precise description of violation, which means you don't have false positives. Right? There's no way it can tell you that there is a violation where there is no violation, because it tells you exactly what the violation is, and you can inspect it. So that's the model checker. It takes the model, the properties, and then produces either okay or a violation, which is a counterexample.
So is there a way then to sort of simulate, for example, if you were to solve this problem in a database, for example, you would probably have some kind of like locking mechanism or something. Can you add that in your Quint model? Say like, okay, I have a lock here or something.
Yeah. So the idea is you implemented some. So you had this idea, right? So I'm Gabriela, and I want to implement a bank here for my city. I don't know. And I go there and I have this idea and I model it in Quint. and then I find that my idea is actually shit and it won't work because I haven't checked like the balances and stuff. And then I go there and I change my idea, right? I improve it, and okay, now I have you said a lock here, like you can. What I did, so this is part of the getting started tutorial on Quint. So what I do there is just I'd say like if I'm trying to withdraw more than I have, then I cannot withdraw. Right, so it's just an if, but it's basically like there is like a lock inside the withdrawal functionality, just more on a more abstract level maybe. So I just introduce that to my model, and then I check the property again. Okay, now it works. Now my model is good enough, and I can start coding it. So yeah, you can absolutely like tweak your model, change it until you have something that works.
And if you're thinking about like because the interesting property to me is the like how these systems like can like these model checkers can model distributed systems where things might happen out of like in a sequence that you don't expect. Like so, for example, let's say that you have this balance. For example, like a common. Or like if you have this balance check and then you try to do 2 withdrawals at the same time, can the model checker also check that the algorithm still works in those cases?
Yes. So the thing there is your state machine is different then, right? If you have 2 processes that can execute at the same time, it's not actually at the same time, but like in parallel, then you have a very different state machine because you have like an initial state, and then you have you have a circle for your initial state, and you have multiple arrows, right? You have one arrow that goes into like process 1. So like let's say that process 1 is like an ATM, and process 2 is like internet banking. So you're a website, right? So you are in an initial state, and you have one arrow that represents the ATM starting a withdrawal, and then you have another arrow that represents the website starting a withdrawal, and then you have a much bigger state machine because it has to encapsulate much more different states, right, and much more different arrows. And then for the model checker, it's exactly the same. So it's just exploring a state space. The difference is in your model. So when you're writing your model and you have multiple processes, you say that your transitions. So in Quint, you have 2 special definitions. You have init, that defines your initial state, and you have step, which defines all of the transitions of your system. And then you can call like additional like helper functions that will define some of those transactions for you. But the main entry point of Quint is the step. So step will say like at any given point, either I'm doing a withdrawal or I'm doing a deposit. And if I have multiple processes, I instead would say at any given point, I pick one of the processes. So one of the processes, so say either ATM or a website. This process is doing either withdrawal or deposit. And there's an important bit here, which is the models are super abstract. So you are the one who tells which level, like what you can do. So for example, can you do atomic withdrawals? Is it possible? You are the one who tells the system that. So if you're modeling your withdrawals as atomic steps in your state machine, so if it's like a single arrow, like you have a state before withdrawal and then one after withdrawal, it's one atomic step, then the model checker will check it as if it was an atomic step. If it's not an atomic step, then you are modeling, you have to be careful to model it like, so first this happens, first like I update some lock or something, and then the actual withdrawal happens. And then suddenly you have 2 steps, and then the model checker will consider all of those interleavings. So it's a super like general purpose abstract language, and you have to define the level of like the tail you want to go to. You have to define your assumption. So my assumption is this can be done in an atomic step. So I model it as an atomic step or not.
Okay, so but there are no like you can't say like, oh, I put the semaphore here or something. You have to sort of model that yourself in your model.
Yes, you have to model it yourself. There are no like primitives for semaphores, for messaging, but it's in such abstract level that it's usually super straightforward to model that stuff. So, for example, some people ask like, are there like batteries included? How can I exchange messages? The the messages, you can just save them. So this is just a model. It's not your implementation. You can just have a state variable, which is kind of like, you can see it like as a global variable. You just create a set of messages there, or if you want messages to be ordered, then you create a list of messages. Then you just put messages there and then remove them from that global variable, and that's your message exchange. You don't have to like implement RPC inside Quint, right? You just keep things on a very high abstraction level. And also like mutexes, you can just put a global variable there and then like Boolean, and then if it's taken or not, it's super straightforward.
I see. Yeah, but I mean, it sounds very like, this sounds like a tool that many more people should be using, I think. Sounds extremely useful.
Yeah, I think as well. It's hard to. It's like very few people are using formal methods still, like comparison to how many should perhaps be using. So I think it's kind of like slowly spreading and making a tool more accessible like this. Like Quint is accessible in terms of easier to learn, a much easier learning curve, much more like integrated into your existing tools, then you can make more people use formal methods. But not only that, we also there's like a two factors in formal methods: the high cost associated to doing it, like learning, starting like and then spending like a week to model something or whatever. So the cost, but then also the gains, right? The value you get out of it. So you get a lot of value out of formal methods because you can formally verify something. Okay. But in order to formally verify something, it's like a lot of work. It's not just write any model and then boom, you're formally verified. Like it takes some work. Formally verification is not given like for granted. But the thing we figure with Quint is you don't always need to go all the way into formal verification. Like if you do, it's great. But you get so much value even before that. Even before going all the way into formal verification, you already get so much understanding of your system. You already identify so many bugs, so many like violations, even before going into formal verification. So what we did reduce the cost of writing a formal specification a lot by like improving the syntax and all. But we realized we also like are adding so much more value. So if you go and write a specification in any language, perhaps the only way you get value is if you manage to do formal verification, which is not going to always be the case because it's hard. But in Quint, you get so much more value. And you can also do what we call model, or not we call, but what it's called model-based testing. So model-based testing is a way to test your implementation with your model by using your model. So you basically get a bunch of tests for free, you improve your coverage a lot. And you don't have to do formal verification for that. Just by having your model, you can already do that. So it's like value you get in an earlier phase, and then perhaps you improve your model, and then at some point you can do formal verification. But you get so much value before, and then it's easier to kind of like convince people to use formal methods, right? Because it's like, oh, you get tests for free, you get this for free, you get a much better documentation of your protocol, because if you currently just use a Google Docs, there's a bunch of ambiguities there, it's hard to understand, and it's not interactive. And if you write it in Quint instead, you're sure that it is precise, that it is correct, and you can also interact with the model. So you have this, we have the Quint REPL, where you can like load your model and then call some stuff and then interact with it. Like what happens? Like, hey Quint, can you give me please a scenario where consensus, like there's some agreement in consensus, and then Quint goes like, does its thing, and then gives you a scenario, and then you can see how the state looks like, and oh, what if I execute this from here? What happens? And then you can generate a test from it, and then drive your system up to a consensus state or something. So yeah, I think there's much more added value, and we are trying to do even more of that. So I think I like to put my time, like improving Quint, I like to put my time into just adding more value to what it can, sort of like adding more ways for Quint to add value for you, and then perhaps that will convince more people to use it. But it is tough.
I think you had a really good point, because it feels like every organization that's big enough probably has some Google Doc somewhere with a bunch of circles and arrows that is like, maybe never worked from the, like, maybe it actually did have a specification bug, maybe it didn't work, and it's definitely not updated, and like you would be happy if it's like, in source control. So like, having any kind of like executable documentation feels like a huge step forward. But this is something I've been thinking about as well. I've been, do you follow Hillel Wayne?
Yeah.
Yes. Yeah, I think he's also a really great resource for learning about this kind of thing. And he has a book coming out soon, I think, called Logic for Programmers, that I'm looking forward to. But it feels like one thing that people often get wrong is some kind of they have this sort of idea that like, oh, why should I write my code twice? Like, but I think that's sort of the wrong way to think about it, because like you said, people, they are doing this kind of, diagrams and like mermaid diagrams, swim lane diagrams, etc. To try to like both verify that they have the right idea, and also to communicate with people. But instead of doing it, I think what I'm trying to say is that like maybe it's the wrong way to think about formal verification as code. Think of it as documentation first, maybe.
Yeah, absolutely. I agree completely with that. And for that, for that kind of subject, I always like to quote Lamport, because Lamport explained this really, really well. And he has a very famous talk in paper called, I don't remember the exact title, but it's something about drawing blueprints before you build something. That's very established in engineering. You will never see something being built without like the engineer drawing a blueprint before, right? And it's like a very good comparison, because and this is also like an argument to write your specification even before writing code, which doesn't have to be this way, but it's better if it is like that. So Lamport makes this argument, and it's like, and then people try to counter argument that by saying like, okay, but it's much easier to change software than it is to change a building, right? Buildings, like, you have to break walls and like super hard to restructure. But that's not actually true, because changing software is actually expensive. Like, programmers are expensive, but not only that, every time you change software, like, there's a very high chance you introduce new bugs that weren't there before. It's a very expensive thing that we often don't see that, but it is expensive to change software. So it's much better if you have a blueprint or specification, and then you can change things there first, make sure that it is correct, and then go into your software and make the changes or implement the software, right? So it is absolutely worth it to write the specifications, and it's not like you're writing code twice. It's just as it's not like the engineers who draw a blueprint, they're not building twice. Like, they're writing the blueprint and then they're building. It's not the same thing. So it's a very different kind of task, and it's much more like writing documentation, make sure your solution is correct before going into and try to code it, because coding is much more like there's much more detail. You have to take care of much more stuff than on the specification level. And there's one more thing to this analogy, which is engineers don't use bricks to draw the blueprint. They write it with like pen and paper. So you should also not use like the same like programming tools you use for coding to do your specification. You have to kind of like let go of some things. You have to try to stay on a more abstract level, because if you try to do like the exact same thing you're doing in implementation, often it can be not as effective. We do kind of do that sometimes. We make specifications very close to the code, but we find that it's much more valuable when we manage to kind of stay on a more abstract level. Like, we use Quint for a consensus algorithm, right? So it's much more like abstract, and then into the implementation of that consensus algorithm is much more detail. There's much more detail involved. Yeah.
Yeah, and I mean, like I guess a common counter argument as well is like, well, how do I know that the system actually matches the spec? Well, I mean, but you're always going to have that problem, right? I mean, if it's a simplified view, it's like that's sort of the cost. I mean, people usually don't say that like, or it's the same way, like, for example, in theory, it would be great if you could generate, for example, like a diagram of your entire system, like from the implementation itself. But that's super hard. And usually it's like, that's not really what you want anyway, because it's going to be, probably it's going to be so dense and so concrete that, like, the important ideas get lost in the mix. Like what I think sounds really attractive with the formal methods and like modeling it this way is that you can stay at that abstract level. So you sort of focus on the important properties and you don't get distracted by all those like implementation details.
Yeah, exactly. That's very true. There is a way to connect your specification with your code, though. So the first sometimes idea that people have is to generate code from your specification and then just use that code, right? So, you have a blueprint and then you just generate the building out of the blueprint and don't have to build it. So
it worked great for UML, right? Everyone is using UML to write their code, right?
yeah, UML, yeah. So I did try to do that. So that at the beginning I told you, like, my bachelor thesis, I tried generating code out of CLA and I succeeded. Like, it works. However, like, to make that code useful, then it's hard because the code generated from the abstract specification is not really a code that you would write, and there's also like the processes. So, for example, we're talking about the bank, right? So there's like two processes. One of them does this, and the other one does that. In Quint, it doesn't know that those are different processes. It's just like, for them, it's just like any other value, like. So when you generate, you have to kind of like help. So you have to add some additional information, say like, oh, this represents some sort of process and this is another. Yeah. And then my tool that I wrote can kind of like read that some additional configuration and then generate it, kind of like the parts of some process. But still, like, I feel like it's not useful for like production use. I think the tool that I wrote is kind of useful for you to understand your specification better, especially like in the TLA days where sometimes it was very hard to understand the specification. If you generate code and then you read the code, it's like, oh, now I understand what's happening because the code I can understand. And you can kind of like learn about specification better. But that's also what Quint can do now. So you can run your specification in many ways. So I think Quint solved the problem that tool managed to solve. So I'm not working on that anymore at all. But as a tool for generating code in production, I don't think it's feasible. Also because many people who are writing formal specs now, they are not writing it beforehand. They already have something running in production and they just want to make sure that is correct. So it's not like we need a generation tool. The way to do it, as I believe, as many other people in formal methods believe, the best way to bridge this gap between implementation and specification is through model-based testing.
Yeah, please tell me a bit more about.
So model-based testing is using your model to generate tests for your specification. There's like many different strategies. For example, you can do, you ask Quint, like, please give me some traces, any traces. Or perhaps you want to ask Quint, like, please give me a trace where Gabriela has exactly $99 on the bank. Right? You can ask for specific scenarios, and then Quint will give you traces. And these traces, Quint has an option to produce those traces in like a JSON format. We use something called the ITF format, which is a super easy to parse JSON format. And then you have like Gabriela withdrew $50. Gabriela deposited $63. And then you have those traces like in a JSON list. You parse them on your code. So like if your implementation is in Rust, for example, we have already a tool to parse those traces easily. But if you have any other language, it should be super easy to implement the parser. So in Rust,
just to clarify, like, so the trace is the like basically a sequence of steps that was taken in the by Quint to like from a Quint run, basically.
Yeah, more precisely, is a sequence of states, not of steps. Yes. But we do have some auxiliary. So you have something in Quint, which is the --MBT for model-based testing flag that will add some additional information about the step, so you can understand what happened between one state and the other, right? Because the states is just like Gabriela has $50 and then Gabriela has 60, and then you can kind of like infer that I did a deposit of $10, but it's not always easy to infer, right? In this case, it is easy, but it's not always easy to infer what happened between one state and the other. So we added this little thing there, which will print which action was taken. So Quint actions is what defines the transition. So it will print deposit, and then you also have some other field there, which is kind of like the non-deterministic picks. So whatever thing was picked non-deterministically, and in this case, it will tell you that the amount that was non-deterministically picked is 10. So yeah, it's not super straightforward, but if you understand the model, you can easily parse the data back into the step and then figure out what happened between one state and the other.
Yes, but sorry. So yeah, exactly. You can generate the data for your test suite.
Yeah, exactly. So then you asked Quint for those traces. It produced the JSON. You go into your implementation language, parse those JSONs in your test suite, and then you say like, oh, if the step here is a deposit, then I will call the deposit from my implementation here, so like from my REST API, whatever. You call it on your implementation with the same parameters that Quint called it, and then you get some result. And this is like a representation of your bank now, like how does your bank look like? And then you compare with how the bank looked like in Quint. So in Quint, the trace, in the trace, your bank now say that Gabriela has 60. Is it the same case in your implementation? Does the bank also say that Gabriela has 50? Then you compare. And if it's different, then it's because there's some difference between the behavior of your model and your implementation, and you can go and try to fix it. So you've been doing that a lot, and you can also check your properties as well. So if you have like a property that says balances never go negative, you can use the Quint traces just to fuzz the fuzzing of your implementation, and then for each state, you check that property, which is something called invariant testing. You can also do invariant testing with any sort of fuzzer. You don't have to use Quint for that, but Quint is one way of doing it. So you basically use the Quint intelligence to fuzz your implementation, go into very different, like first there's like deposit, withdraw, deposits, like one trace, and then you try something else. So you're fuzzing it, you're playing a lot of different traces on it, and for each state you're checking that your property is true in the implementation. So it's kind of like a way to connect both.
Yes, very. I don't know. Yeah, I'm sold.
Good. Yeah, it's a like perhaps even the first way, or yeah, maybe not the first, but one of the ways to get value out of Quint. But the first even is just using. So we have the Quint simulator. I haven't talked about the Quint simulator. We have I talked about the model checker. The Quint simulator, it does the same thing as the model checker in the sense of it also has the same two inputs, the model and the properties, and it will output either OK or violation. The thing is, the simulator is like very lightweight, and it won't examine the whole state space, because that is super expensive, especially if you end up with a big state space, which is most of the time. So because the simulator will explore like 10,000 samples or however many you tell it to do, like by default 10,000 samples. And then if it cannot find any violation, it will say, okay. It doesn't mean that there is no violation. So this is not formal verification. This is just simulation. So the reason we did that, the reason we implemented the simulator the first reason was people who are learning formal specification, formal methods, they write their model, and then the first thing they ask us is, how do I run it? Like I wrote this code here. How do I run it? Where do I click? And the usual answer was, you don't. you model check it. You cannot run. You just model check, which means you are going to explore the entire state space. It's like a big deal.
But and that can be huge, right?
It's
like
often
said,
huge. It often grows exponentially. Yeah. It's called the state space explosion in this context. But yes, just combinatorial because it's like it scales exponentially, right? The more actions you have every step, then it scales a lot. So yeah, it's a very big challenge. And then the person is usually like, I don't want to model check it. I just want to run it to see what it is doing. And you are like, yeah, they are right. Like you just want to see what it is doing. You don't want all of the possible traces. You just want a single trace just to see what happened.
I want to run my program, Gabriela. How do I run the program?
So we implemented something on the CLI. It's called Quint run. You're running your model, and what it does is just going to run 10,000 samples of your model. You can also run it a single, like if you do Quint run max samples equals 1, it will run just a single trace and give you a single trace. So the idea was like perhaps people can start with that just to inspect what's going on, and then they can proceed to verification. But it turned out to be much more useful than we initially thought, because it actually catches many bugs. So it basically our process is we use the Quint simulator until we cannot find any violations anymore, which is usually like weeks. Because we find it's usually modeling mistakes. Usually not like there's a mistake in the idea, but like, perhaps we forgot to update something here and there. Like you tune your model. Okay, now my model, like, I cannot find any violations with the simulator anymore, and then I proceed to the model checker. Because the simulator is much faster to run. It doesn't have like any, like, it's a very simple tool. It just randomly executes stuff. So it made us much more productive. And when the simulator doesn't find any bug, we are usually very confident that there is not any bug. Like sometimes the model checker can still find something with the simulator cannot, but it's very rare. Most of the cases the simulator is enough to catch bugs. So it's super interesting, and also like another way to add value. If you, in some cases we don't manage to use the model checker because state space is too big. We don't have time to try to like reduce it, because you have to be smart about reducing your state space, right? Because you have to think.
Yeah, are there any like techniques for like doing that in the model checker itself or inside Quint?
Yeah, so there are two model checkers for Quint, or for TLA Plus that Quint can also use. The model checkers were actually made for TLA Plus, which is use the same tools, because we are not writing a model checker from scratch.
That sounds complex.
Yeah. So it's actually not super complex. Like we might try to turn our Rust simulator into a model checker. I don't know how hard it will be. Like I have a sense of how to do it, but like a very simple model checker, I'm sure. Let me talk about the strategies, right? So there are two model checkers, the TLC and Appalachian. TLC is what we would implement as a model checker if we, like, you and me here, let's spend like a day writing a model checker. That's what we would do. It does the intuitive thing of like visits the first state, checks the property there, and then see the transitions and where we can go from the first state. Then puts them in a queue. Then it goes to the next state in the queue, does the same thing, adds more stuff to the queue, goes to the next item. So it basically explores the state space.
Yeah, like breadth first.
Breadth first. Yeah, you can also use it with depth first. I had never done that. I'm curious to see how it does it. I haven't tried that yet, but it does breadth first. And the breadth first, and if it finds that the same state, so it finds a new state and it's equal to something that it already visited, it uses like a fingerprint algorithm to make sure it's similar. Also, if I've already seen this, then it doesn't process it again. And then if your state space is finite, then it will end. If it's not finite, you cannot use TLC because it will just run forever. So you have to make sure your state space is finite. That's TLC. How do you reduce your state space? If you're using TLC, you have to literally just reduce the number of states. So if you're considering you have like 4 processes running something, like in a distributed systems, right? You can reduce to 3 processes, then the state space is much smaller. or if you can reduce like the max number of steps it takes, or if you can reduce like in the bank setting, I have to choose an amount that I can deposit. If I do, instead of doing like some amount between 1 and 100, if I say the possible amounts are just 1, 5, 50, and 30, I don't know, like I just pick some amounts, then state space is much, much, much smaller because I just reduce the number of transitions so much and the number of states so much. So that's how you do it. You just have to think about it and then reduce the state space. And then the challenge is, am I missing some important scenario by doing this, right? Is there a bug that can happen if the person deposits $75 instead of 50? Like, am I missing something? It's a bug that only happens if I have 4 processes that I cannot reproduce with 3 processes, right? So you have to be smart about what you're pruning to make sure you're not missing important scenarios.
Yeah. And it has to go like be in the design stage, basically, of the problem.
Yeah, you have to kind of like make compromises and perhaps even think about some stuff yourself. Like, is this enough to find all the bugs? Maybe. But that's the only, like, there's no complexity. For Appalachi, the other model checker, that's not how you and me would write a model checker, unless you are a genius. Because Appalachi does something much more fancy. It translates your transitions from your state machine into SMT formulas. SMT formulas is satisfiability modulo theory, right? So it's basically a bunch of constraints that have to be solved. So like, A equals to 1, B equals to 2, and A plus B equals to 3. And sorry, I shouldn't have said the first part. So if I say A plus B equals to 3 and B equals to 2, then you have to find a value for A, right? So it's a bunch of constraints to solve. And then Appalachi calls the Z3 SMT constraint solver and solve those constraints. And then that's how it can say either okay or violation and give you a counterexample. But this process of translating the formulas into constraints is super complicated. So it's not like for all of us to understand and then optimize. But it means that you can even work with non-finite states spaces in some cases.
It's like it can rewrite those into sort of like
like numbers, for example.
Yeah.
For example, like for the amounts that are in the balances, if I'm using Appalachi, I don't have to constrain. I can say like any integer, because Z3 can handle integers, right? So we can just say like, it just turns that into an algebra formula for the bank, like deposit, withdrawal, and then the ending value has to be greater or equal than 0. And it's just like a formula. It doesn't have to constrain the number of values and then enumerate all of them. So for Appalachi, it doesn't help to reduce the number of amounts they can pick from. For Appalachi, I have to be much smarter and kind of like reduce the complexity of my model if I want to optimize things.
Because you have to think that like, all of these, like, so instead of thinking of like, the state space, you sort of have to think about like the complexity of constraints. Is that?
Yes. Yes. So yeah, normally if I find it much easier to try to reduce state space and use TLC, but I always try to use Appalachi and see, like, because sometimes Appalachi can be much faster than TLC. So I try Appalachi. If it's not fast enough, I usually don't have the skill to like optimize.
Yeah.
Some people have, some people do, and then they manage to use Appalachi really well. And by some people, I actually mean like the people who made Appalachi. They understand it really well, and that they are using it very successfully. It's an amazing tool. But I find it easier to try to just reduce the state space and use TLC because I can predict what happens much better.
Yeah, I guess it's sort of I guess it helps if you have some like, I don't know what to call it, like mathematical intuition or something, to say like, okay, what is the smallest possible system that still has the properties that I'm interested in, for example. Like, if you have if in the bank account example, like it shouldn't really matter if you're trying to check that someone always has balance greater than 0, shouldn't matter if everyone starts out with like 10 money or like 1,000 money, for example.
Yeah, there's some stuff like that. And that reminds me of something called inductive invariance, which So the normal properties we define are just invariants, something that doesn't has variance, or it's true all in every single state. So there is no single state where it is false. This is an invariant. An inductive invariant is something like that, but that you can verify inductively. So you basically only need the initial state and then one transition, and then you verify in a special way that then you can make sure that it holds for every single state of your system without having to enumerate them, just by verifying it inductively. But then you have to be really smart about it, and then that's kind of like the thinking that you were explaining to me now. It's very much like the thinking of inductive invariants, because you kind of like every state can be your initial state, and then you just do one transition, and then you verify that if after that transition, which is any transition, the property still holds, then it holds for the entire state space. So that's a very, very interesting strategy as well.
Yeah, it feels like, if you start scratching the surface, you sort of, it feels like you're sort of approaching the foundations of logic at some point.
Yeah, and that's why people who have deeper understanding on logic, they can write really good specs, right? How, like the Appalachian people, the developers, like Hillel. I'm also looking forward for the book he's writing, because I think it's all comes down to the logic.
Yeah. Are you familiar with Peter Olborough? He's done a bunch of work in he has a really good talk as well that I can recommend. I think it's called I See What You Mean. I can link to it in the show notes. And he has a kind of similar observation that says that a lot of the hard things about distributed system is when you have non-monotonic properties. So, for example, he has this example where, let's say, you have a distributed list, and the only operation you can do on the list is to append things. And if you ask a question does this element appear in the list? Then it's very easy to make distributed, because that property will always hold. It doesn't matter. But if you want to ask the inverse, does this element not appear in the list? Then all of a sudden you have a really difficult problem, because at any given point someone could have appended the element to the list, and you don't know, then you sort of have to have complete knowledge of the entire system, because that's a non-monotonic property, I think it's called.
Yeah, interesting. Makes sense. Yeah, it reminds me a bit of dependence types, which is also a whole other thing. But I guess Quint is more on the field of, it's good for, you can write any property, right? And then it kind of it's the same strategy for any property. And then if you have one property that can be proven in a easier way, for example, type safety. You just use some type system. If you want to get rid of those rounding bugs, just use a static analyzer for your code. Don't go into Quint for that. But then Quint is powerful to show, to work with any property. And then if you have special properties that have better tools for that, just use those tools. But then if you cannot use the other tools, then Quint is there for you to think about any property. It's very general.
Yeah. And I think regarding the thing you said before about the complexity of the model, it sort of brings home the point that it's these kind of things, they're good to bring out for specific problems, right? If you have some part of your business logic in your application that I don't know, there's a bunch of you're suspecting that there might be a concurrency problem, or you're trying to work out how some new feature is supposed to be made thread safe or something. I guess then it's a good opportunity to just model that part in Quint, right? You don't have to model the entire application and all the services, etc., etc. Just you would only when you're diagramming things or making a graph, you only do it for the things that you're interested in.
Yeah, exactly, and that's a bit of a skill to learn, but when you manage to do that, then it's it feels really good, and we've done that recently, like in a project here, and we managed to kind of like stay in scope and only model the thing we were worried about, and managed to abstract away all of the other pieces that interact with it, and just model it in a very like black box way. This component just does this without going into detail, because the components often interact with other pieces, right? So it's hard to just model that without thinking about the other pieces at all. But the more you can abstract the other pieces, then the better it is to just reason even about the part you care about. It's very interesting.
Yeah, like narrow down the scope. How are we doing for time? Do you have to run soon?
Kinda. I do have a meeting. It's not super important. I told them I'll be late. But I guess you wanted to do like a 1 hour podcast, so we are already a bit over time.
Yes.
Sure.
Yeah, I was thinking maybe it's like, time to, maybe it's time to start wrapping up. Thank you so much, Gabriela, for coming on the podcast. And for all you people listening, well, this was the Func Prog podcast, and I'll see you next time.